predictive modeling is widely used today. It's scoring, it's trying to predict what people will do, when they will click, what they will buy, when they will churn, and so on. Predictive modeling is part of the Enginius package. And to demonstrate it, I'm going to load the data from a fundraising context. So in that fundraising context, what we have is a bunch of customers for whom we have observed their loyalty over the last 12 months. And 12 months ago, we measured their seniority, recency, frequency, and average donation amount. So that person here was acquired 22 years ago, made her last donation 12.6 years ago, very cold donor. Between that period, made 6 donations with an average donation amount of $43. So we're going to predict the links between loyalty as a target variable and all these independent variables, and then try to apply that model to a new data set which has the same variables but contain different customers. Now it's a very complex model because when you think about loyalty, it has 2 components. One, whether or not you're going to make a donation, and 2, if you make a donation, how much are you going to give? And that's called the discrete-continuous model, which now is implemented in Enginius. What you do is, in predictive modeling, you select the kind of target variable you have. So you can have a binary variable, will buy, not buy, a choice between multiple alternatives, such as which brand the customer is going to choose. Continuous, that's regular regression. And then discrete-continuous, which is yes, no, and for the yeses, how much. I'm going to use the in-sample. The loyalty is actually my target variable, and I'm going to transform both input and output to improve the predictive ability of my model. I'm even going to use a tenfold cross-validation, and once everything is done, I'm going to apply my results to my out-of-sample data. So the model works in 2 steps. First, we describe the data that has been used, both in-sample, out-of-sample, and how we normalize the data with box-Cox transformation and so on. And then we run 2 models. The first one is the discrete model, who is going to make a donation and who is not, with plenty of diagnostic tool, model predictions, confusion matrix, and of course the gain chart and lift. Actually, the model is quite good. It has a lift of 4.71, which is quite efficient. And then for those who actually made a donation, we move to the continuous model results, where we try to predict the actual donation amount everybody has made. And here the model seems to work pretty well. Once you have that, you combine these 2 models into one and get the gain chart of the entire model. As you can see, the dashed line is the multifold cross-validation process, and it usually tends to be a bit less optimistic than the in-sample fit. And once it's done, actually that model is then applied to compute elasticities, the changes of predictors on the out-of-sample, and then for the out-of-sample predictions, everything we need to know about our sample, and of course the predicted lift is pretty good as well.